Hello, good night. This is December 4 session of the OPIS 112, and we're focusing on Lab 5 before going forward on this session. Any question any of you may have about the activities that we identified on the previous sessions on the OPIS 1 and 2? No? Okay,
good.
let me share it with you the activity that we're gonna do. Okay. This is a web assign. If you don't see it, let me know. The one that seeing as a web assign curriculum, and we go to the my courses on the lab 5. As we mentioned just briefly, this is a distance ladder candle, standard candles that we're doing on the lab 5, and this is pretty extensive, and it is we're gonna learn based on this 3 procedures. One, based on the variable stars of, they call it RR Larry, measure the distances of the object within the Milky Way galaxy. This is nearby object. When it has become a little bit more to the galaxies nearby, we want to use the Cepheid variables. And then farther distance galaxies, we can use it type IA supernova. And therefore, this is the 3 candles that we have for the standard candle. We're going to use it. And the last session, we just reviewed the magnitude system, apparent magnitude, the magnitude that we see it from the Earth. Actually, is on the dark sky, it's going to be between around magnitude 1 to 6 that was created from ancient time, but we just expanded that kind of sense of the measurement to the larger numbers, like the sun is minus 27 or moon is minus 12.6 and other stars. And for example, brightest star is minus 1.4, although in ancient time they call it magnitude 1. But anyway, that's Pluto is plus 15.1. Whatever about 6, that is naked eye limit, you cannot see it by your eyes, but you have to use it binoculars or large telescope, small and large, to see it further. And then we just review the one simple example on the activity that we have on the Astro Lab, Astro 1 lab, that is related to the how to measure photometry on the sky, and that is called CD47. And then we measure, normally these pictures comes from ABSO, organization of the amateur astronomers to do the variable star investigation. And they have also remote telescopes available. However, member of the AVSO can assign a research project and ask for the pictures like the one that we have on Skynet and the LCO observatory, but those is not very easily programmed like Skynet. And you have to do some post-processing, and you have to submit your proposal and they have to approve it, and then you go further after that. But these pictures that you see it on the Lab 5, it comes by collaboration between Skynet and AVSO, and this is one of them that we start with that. And we just identify that whatever you see it on the sky, it looks like a similar magnitude, same brightness, and but might be on different location. One of them might be very big and one of them smaller, but the big one is farther down and the smaller close by. Therefore, apparent magnitude seems usual, same. And the one consideration for this is that we calculate the uh, brightness and the distance and magnitude with simple this equation. Yet it means that you assume a big circle. I think around the sky, and the surface of the circle is going to be 4 pi d power 2 a sphere, and if its diameter is d, and the diameter is distance between us and the star. And therefore, if we create this formula, this means that L luminosity and B is brightness. L representative of the luminosity, actual luminosity, but when we get farther away from the star, the brightness has become smaller. And this formula creates very good proportion on that. If you assume luminosity in the close by is L, and then when you make a distance of d, it reduces it by this amount. It's very clear. You don't need it to memorize. Just keep at this sense of the proportionality. Therefore, we have two things. One apparent magnitude that shows by brightness, one actual magnitude that is showing by L, luminosity. One of them we call it luminosity. It's close to the absolute magnitude, and B is the brightness or apparent magnitude. And as we mentioned, and here normally we using this formula by the professional astronomers to calculate the kind of distance based on the M and M, capital M and lower M is that difference is that apparent magnitude or similar to the brightness of B is M, small, capital, not capital. The capital one is the absolute magnitude corresponding to luminosity. Therefore, this is the main two concepts that we had based on the distance, and we get based on that this formula after we just solving this equation. You don't need it to learn how to solve it or remember it, but everything is here on the lab 5 is available. And also, we mentioned that this is a Cepheid um, uh, typical curves. It's not going to be exactly like a smooth like that. It's going to be some uh, deviation from the smooth graphs that you see it here and here. But one of the key items here to notice is that peak-to-peak value, distance between them, if we have time on the lower axis and the brightness, apparent brightness on the upper vertical axis, the peak-to-peak distance going to be period in any of the graphs, either for the Cepheid or parallel. And whatever else we have is one of the key importance between the difference between RR and Cepheid is that in the RR most of the time period is very small, is smaller than 1 day. As you see it here, probably from peak to peak is about 0.6 of the day, 60% of the day. But in here, in the Cepheid, the period here, for example, this is about 1.5, and this is 4.5, is about 3 days. The duration is going to be longer. And one of the key things that we know, based on the practical observation of the astronomers in last centuries, it is RR have approximately the same average absolute magnitude. M capital is always 0.75. And why it is like that, we don't know. This is kind of things that we have to go further down, and we don't want to go more on astrophysics and other items. We had some criteria and theories for that, but we know that all of the other layers that we have studied in the sky, on our Milky Way, the absolute magnitude is about 0.75. And that's one of the key things that are important in our evaluation. Consequently, if the variable period relieves to be our value and m is equal 0.75, we can get the distance very quickly. Why? As we see it in this formula, if we calculate m based on the graph that we get the data from the Afterglow and Skynet, then we know the 0.5 m capital, And based on that, you can get the distance based on the kiloparsec on this formula. And therefore, this is very easy way to calculate RR-Larry's distance. And also on the Cepheid, a little bit different. And RR-Larry, as you see it, all of them align in one line, luminosity, because they have all luminosity is the same. But on the Cepheid, luminosity is not same, like 0.75 here. It is proportional in the like a graph showing here. The graph here that is representing the Cepheids, it seems to be linear from here to here, is like a line. But it's actually because here it is the division of the um, period of the pulsation period and also luminosity. They're not actually linear, and it is based on the logarithmic section. That's the reason that it turned out all the Cepheid star has average absolute magnitude that approximately related to their period. It's not it's constant, the one that we see it on RR layers. And because of that, this equation developed by the astronomers after Henrietta Sweet that discovered in 1912 in the Harvard College based on the investigation of the variable stars. And if we know the period, and we can get the absolute magnitude. And when we have absolute magnitude, we can go back to that formula here. We after period we get m, and we know the um, apparent m. We can calculate the d value. Therefore, both formula is applicable for all the cases that we have in here, and both LR and other Cepheid variables on the consideration. And also, if the variable period relates the Cepheid, therefore, this is kind of things easily can be used for nearby galaxies. Most of the Cepheid are closest to the nearby galaxies. There is about 60 or 80 plus 60 plus nearby galaxies for the Milky Way exist. Do you know the some of the nearby galaxies by chance, Rowan or John?
Nearby galaxies or nearby Cepheids?
No, nearby galaxies. Or galaxies is Milky Way, but nearby galaxies to the Milky Way uh, that
Think the one with the big A.
Andromeda?
yeah, very good. Andromeda is one of them. Is about one of the closest um, galaxies, and another two small, one large Magellanic Clouds and
Yes.
small Magellanic Clouds that is not observable from here. You have to go the southern hemisphere on the Southern America or Australia can see it. Therefore, those three is the main one. But for a long time, I will say around 40 or 50 years, they thought this is only nearby stars. But after that, and recently, also many of the astronomers, specifically on Chile, CTIO, based on the investigation, and ALMA, they discovered there is plus 60 nearby galaxies to the Milky Way. And suddenly become from 3 become to the 60, and that is growing. It means that there is a many unknown item available on the sky that we have to discover. And that's a brief story of the that and also Cepheid we using normally on the large and small Magellanic Clouds, or some of them on Andromeda or nearby galaxy can be used to get the distance. The distance in here is different than the distance on the Earth. When we get the distance, for example, from this side of the room to the other side of the room, is exact on the matter of the inches or so. For example, from this side of the room to the other side is about 10 feet or 12 feet or whatever we have, or 10 and a half or something like that. But when we get the galaxy itself is very large. for example, may have several 100,000 light years from this side to the other side. And when we find the Cepheid inside the galaxy, it might be somewhere inside, but that it doesn't mean that if we get the Cepheid distance, we can get the distance from the center of the galaxy. That Cepheid might be on the edge of the galaxy, and also there's different. But the problem, this is not the problem, because as long as we can calculate the distance of the galaxy in matter of the several 100,000 hours plus minus, it's going to be good enough. For example, if we know the Andromeda galaxy is 2 million light years, it doesn't mean that exactly 2 million light years, because we know that from this side to the other side has several 100,000 years, and therefore that concept of the measurement that we have on the Earth, we have to change a little bit to get familiar with the astronomical distances. And that's because of the huge size of each object we're looking, either nebulas or galaxies or other futures has a long distance from one side. It's not like it's just a point. They have very large solid kind of gas composed of the many different things inside. Anyway, this is kind of very background about the supernova. Normally, the supernova, when it is happening, they are the type of the exploding stars. They occur when a compact star called white dwarf orbit to a closest giant. Like, for example, if you consider this is white dwarf and this is a giant star nearby, and because of the large amount of gravity from this growing white dwarf, it collected the mass from the giant red giant nearby. And near to that object, it creates an acceleration disk due to that material comes to the white dwarf. And then um, the increasing the mass of the white dwarf until it began to collapse under its own weight. And when it happened, white dwarf collapsed and heated up, and then the temperature rises and the carbon fusion occurs on the center. When it has happened, and then explode, the entire star explode, and we call it this as a type IA supernova. And that's another way of the stars that we can see it, as you see it here before explosion, and after explosion, the center star remain, and amount of the gas is expanding from the center. And this is very typical geometrical way how that explosion happened. But on the graph, we look through the graph that we had it. We have identified two type of the supernovas, one type I, one double I. The one that is one I is blue. It means that suddenly the brightness, luminosity goes up, and then we had a hip over here, and then decrease it slowly to get the lower brightness on the luminosity. As you see it, we have luminosity here and absolute magnitude. We don't talk about the uh, other items. As you see it here in the this object that we have here. On here, we have apparent brightness. We call it brightness. But the next graph, on this graph, and this graph, we're using the luminosity. Therefore, it means that on these two graphs, we're just taking apparent magnitude that we're measuring by the pictures. But here, we're calculating the luminosity to understand the better future of the physics of the system. And the difference between the type 1 and 2 is that type 1 has a peak, gradually reaches a peak in very short amount of time, and the peak gonna be slowly decreased. But type 2 is gonna be similar, slightly higher than type 1 gets to the magnitude of the luminosity, but it comes and have some uh, constant luminosity stay for several months. For example, as you see it on this example, from here to here is almost around 90 days. It means that it is going to stay in the, it's not going to be like this hip and suddenly gradually decrease it like this. It's going to have about 3 months uh, at the same level of the luminosity and then gradually descended and become fainter. And therefore, this is a two different configuration that we're going to learn on this activity. And then another fact that we have here, if supernova light reveals it to be type 1A, magnitude is always absolute magnitude is minus 19.3. And therefore, this is one of the key things that help us to get the measure the distance. It is strange. Why? It is the question is that why all of them is minus 9.3. This is based on the actual practical measurements of the many of the data that we had from various type IA supernovas. And the reason for that, there is many theories. We don't want to go through those, but this is the same actual magnitude we have on the supernova IA, and similar way to the RR Larry that we said this absolute magnitude is how much was?
0.75.
0.75. Therefore, this is for the RR Larrys and IA supernova, we know this. We don't need it to calculate. For all of them is like that. If we had 100 of those or 200 of those, all of them, we can take it, if it is RR Larry, 0.75, if it is supernova, 19.3. And then we're gonna come on the actual action that we're gonna do. This is RR Larry, one of the example here. It's gonna be similar activity that we're gonna do. What we should do, you see, for each of them, 4 pictures showing. The reason is that sometimes when you open the picture, uh, based on the different telescope that is taking, might be you see it the this bright star here. But on another telescope, you see it here, you see it here, you see it here. That is because of the different lenses and also the mirrors that you're using on telescopes, they are different. And when you look through the deep sky object, sometimes you don't recognize which one is which one, which orientation. But this is one of the key things that in astronomy for the celestial object, deep sky object, is not very important. But when we calculating the reference, the variables photometry, it's important to recognize which one is the reference file and which one is the RR variable. And for all of them, we're going to have one reference file. That reference file is the star that uh, is not variable, or the variability is very small compared to the RR that's showed by a graph, and here like the one that is changing like this. But if it is a reference file, might be small bumps along the whole period of the days it's going to happen. Therefore, we comparing the graphs together and identify those, and then we're going to show it on the Astromancer how we can deal that. This is one example. You can do it any of this. This is some of the example for the lab activity NGC 1261. And you don't need it to take a picture, but you need it to get from Astro Lab data available. This is 321, 3201, another one. And for all of them, RR Larry and reference file is identified. And this is another global cluster M28. And similar way for the when you do the activity on WebAssign, you choose one of them as you like to proceed. And if you wanna, you can do it repeated while you choose all of them and submit for all of them, but the last one gonna be saved. And then after that, we're gonna go after Glow, Astronomer, sorry. In Astronomer, we get the graph. And when we get the graph, we calculate the brightness and the uh, distance that we had and go that procedure. And same thing on the Cepheid. On the Cepheid, we have 6822 NGC. This is one of the item that we had. And I think only on the other Larry, we have um, 3 options that we can choose. And in here only we have one option that the Cepheid is identified here into two configuration, and then you can look through it. And also remember here, reference file magnitude is given. You don't need it to know. And we're gonna see how much we can calculate on the quick uh, go through item you have. And also for all of them, reference star magnitude is given. Okay, let me go choose one of them. Let me know which one you wanna proceed.
I think 3201 looks like a good one.
3201.
Yes.
Okay, this one. Yeah, okay. We go, let me share it with the, you see the
Yes,
Skynet?
I have visual on Skynet.
You see it?
Yes.
Okay. Then we go to the Afterglow and we just log in the Afterglow and we delete whatever we had before. And we go to the open the file, samples, Astro 101 lab, and standard candles lab 5, and the 3201 here. You find
Open
it?
all, open all in the folder.
Yeah. If you go to the folder, you see there is many of the pictures are there. And therefore, this is kind of various pictures is taking, this is, let me see how many pictures you see there, 50 pictures on different time. The reason that 50 pictures is taking to on the different time to make sure that we have all the graph and the points of the graph available at the time. You choose all of them and open all of them. Okay. Then you see first picture comes with the brightness in here. Then you zoom it in. And okay, here you don't recognize based on the web assign. Where was the web assign? We are like this, but on the Skynet, we are like that. What we should do on the first tab, we're gonna go inverted. As you see, this picture is more matched with this one. And we can do it, just make it smaller, this one, and bring it to the other menu that we had for the, let me see where we was. I think I have to open it differently. Let me open it different way. Or I make it a little bit bigger on here. Let me see. How can I make it bigger?
I think I see the stars for our
Okay.
3201. I think we're in the like fourth image because you can see the distribution is sort of down and to the right.
Okay, yeah. Therefore, let me go like this as we are on this stage. Okay, we have to figure it out what's the orientation around this one. As you see it here, you see a triangle like this that has one star on one of the sides. Then I go back to the afterglow. As you see it here,
Hmm.
where is the triangle? Probably let me rotate it again. Make sure that, let's see where we are here.
Yeah, there's an easy way to invert all of them. Isn't there? If you go to the control, show workbench settings, aren't you allowed to
Yeah,
go
yeah,
shift all
yeah,
of them inverted?
yeah, exactly. That's another thing that we needed to go to that setting, synchronize, before synchronizing, we have to make sure that alignment is good. Uh, as you see it here, this three stars that we had here, probably, correct me if I'm wrong. It is, let me see here. As you see, this is three stars in here. As you see,
Mhm.
there is another three stars here. Let me see where I am here. As you see it, this is a three star as you see it here, going this way. And here, that three stars going that way. Therefore, I have to a little bit rotate it, also like flip it Probably this way. No. Reverse. This way. No.
We try to match up that one, yeah.
Yeah, make sure that we are okay.
I think the reason why they have four orientations is because any one of the orientations would work. I think that you just look at like that central blob in the middle and it's like semi-major axis and which way
Yeah,
that's pointing.
you're right. I think you catch the good point. Let me see whatever we have and see which one we can consider. Let me rotate it another time here like this. And here is the facing down. Let me go here. Let me see which one is the match with this one.
I'd say it's the upper left from where I'm looking.
Upper left.
Mhm.
Yeah, this is the one facing this way, this triangle. Let me do it that way to see if it is when it has happened. Okay. No, it doesn't help here.
Mm.
Yeah, you have
We
to
need
rotate.
yeah, there we go.
Which one?
Yeah,
No.
now let's see what you have.
Here, the problem is that this is facing this one, but here, it here facing this one. Let me
Oh,
see the other one. This is the most challenging part of it to make
Mhm.
sure that we align it correctly. Okay.
Oh, there you go. Let's see. It's like
Downward.
flipped.
No. Mm, yeah. 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 Here, I think we get this is facing this way, and here it's facing this way. Again, we had the same orientation. Hopefully, after many times, based on the this one that we have. You see this triangle facing upper left,
There you
and
go.
here that triangle facing upper left, and therefore we are match. And here, as you see it, these three stars uh, on the corner, probably that three stars in the corner, as you see it, this pattern here, similar to the pattern here. Therefore, the stars that we have, this is our Larry, and there is one star between, and the reference file on the other side, like a enlarged triangle. And here, this is our Larry, this is a star between them, and this is reference file. Do you see it?
Yeah.
yes.
This is a little bit difficult to find, but this is our Larry, this is a star between them, and this is reference. As you see it, this is our Larry, this is a star between them, and this is reference file. And let me go back here to see the magnitude of the star as the reference file is 13.6. Therefore, we can double check here. For the magnitude, after we find out the location, we come to the two things that we have here. One is that photometry system that we had here. When there is a star on the new version, on the video of the professor Dan on the tutorial is different because that was the old version. And the new version of the Skynet going to come shortly, probably next year, hopefully. And here, when you choose for the photometry, make sure that this centroid click is on, tab is on, and all the tabs in here also on. Include the include source from the other files and source markers and marker labels. And the program after Glow itself mark it down. We cannot change it, the marking, but we have to know which one we click first to identify. Normally, uh, I will say it. I will first do it the reference file, then second the RLA. This is dependent on your choice, but which one is the reference file? Upper one, and lower one is RLA. Then I click. This is the reference file. As I click, you see label is one, and then it provide all the other information accordingly in here. And this is RLary, but this one is only show the coordinates. Let me see. Let's say this one close. I think something is this thing over here. Yeah, here. When I click this one is RLary. This is reference file. This is RLary, and one of them is the magnitude is the 13.7. Another one 14.2. What was the magnitude of the reference? 13.6. As you see it here, 13.7 is slightly different. You know, this is kind of things that in astronomy, slight variation is not a big deal, like the regular meticulous mathematics on the regular date. And when we find out this one, we just go here and synchronize the display setting and orientation. And when we do that, therefore we are good. I think if we click on the next one, you see this one is also identified, although we have to invert it all of them. And this one is also identified. You don't need it to repeat everything together, although it takes time to first one, but you have all of them is available on here. And you mark all of them. And this is one. Therefore, on here, remember, first you go this one that is a star, and then in the lamp in here. First one show the coordinates and location and marking, and the next one show the actual magnitude and flux of the light, the photon. Then you go all of them. You choose you can choose from this one all of them directly, but let me first, after I click all of them, I do it after that. I click all of them and identify all. I think everything is set up. And then whatever you needed to do, all of the values, for example, if you compare to this one, you see the orientation is changed, but the item that is choosing is there. And here is the magnitude of the reference file 13.1 and magnitude of the variable 13.4. Here is different. And but the changes on the reference file is smaller, but changes on the magnitude of the variables are larger. Therefore, remember the label 1 is reference file and the 3 is the RR. Then we just, for the getting the data here, click on this arrow here. When you click arrow, you're gonna get a Excel file at the end. And then let me see here. Yeah, let me see why it happened. Only it shows us one. Okay, let me close this one. Let me do it another way. Okay, oh, I forgot to identify this one. I think we select all of them and we identify this and then open up again. Okay, here is only shows one. Let me see what happened here. Oh, here, I forgot. Then select here on the bottom. This is photometry updated only because we selected one. But because here we have all of them. The only things that you needed to do before selecting, just select all of them here. When you select all of them, you see here, all of them is selected and this starlight is happening. Then download this time. This time, gonna bring everything together. Why it is not happening again? Yeah, here, hold on, select it. Okay, yeah, you have to click on this slide to make sure that all of the data on the job is bring it on this Excel file. Instead of this one is only identified for one of them. That is, you see it on here, click it here. But the one that you needed to have to select here all and double click on the star lump that is highlighted here, and then you download everything here. That is the gonna show the all the files.
Now that's a wall of data.
Yeah, that's right. And this is kind of things that a lot of data you have to kind of select. First, you have to organize it in a way that you can see it better, identify it. And let me go over some of the item here as the file ID and different ID. As you see it, SRC source 1 and source 3. Source 1 and source 3. What was the source 1 and source 3? Is the one that we had it on the, do you see my Excel?
I just see a big gray screen myself. Ron, do you
Yeah,
see
same
anything?
here. I think it just needs a moment to load.
Okay, just let me do it again. Yeah, I think, yeah, it shows on different things. Okay, here, as I open it, you know how to get at this one on the procedure afterglow, right? John and
Yes.
Rowan?
Yes.
Okay, here on the afterglow, we have a reference file is one, and the reference the RR Larry was uh, 3. Here they added SRC on the before. Therefore, SRC1 source 1 is the reference file, and SRC3 is the actually the RR Larry. That the variables that, and this is a time for us is not important. This is Julian day, and this is modified Julian day, and this is the coordinate RA and declination, and this is the coordinate on the galaxies. And here the filter is used, and all of this data may not be important, a lot of data. But the one that is for us is important is this magnitude that we have here. As you see it, this magnitude is the one that we needed to upload on the uh, uh, data that we have. Okay, then I will stop here just quickly. We are on the top of our, if you have a time, few minutes, we can go and show the other one as well. Do you okay for a few minutes extra?
Yes.
Okay, then we go here. Let me see it. We go to the,
We've got to sort this data, right? And then drop it in source one and source two to Astromancer. Is that the way we're
yeah,
going?
yeah, I have to get Astro answer, open up, and you do the same. You
Yeah.
see the Astro answer in my,
Yeah, the
Yes.
variable.
Variable?
yeah, we go to the variables. And here, as you see it, uh, the item that is here we needed to capture is the one Julian day, one source one and source two. And this is the kind of things that we needed to populate. Therefore, as you see it on this picture, there is a graphs that is comes from the previous data that we had it here. Therefore, here you can easily delete those, and then you have nothing here. Then you go back to the,
Professor, this
yeah,
is where we may reach a problem. For the SRC3 and the SRC5 are not separated. They're like one after the other, like 3 5 3 5 3 5. So how will we sort out the SRC3 from the SRC5? Or do we have to manually go in and copy paste
no,
it
no,
in?
no. I think there is a way. I think the process
Yeah.
that I did it, I think I did it wrongly. Therefore, that is happening because of that. Therefore, I think we have to clear. Let me clear this one up.
Now, we could do each one individually, or you can do a sort in Excel. Excel will let you sort based on the ID, and I think that'll sort the whole set. I just did it actually, and it looks like it did it for me. Do you want me to share my screen real quick?
Yes,
Go ahead,
please.
John. Go ahead, John.
Okay, I'll pull it up here. So, um, here we go. All right, so we got the whole thing here, and what I did was I went ahead and I highlighted on B. I hit that one. And up under sort and filter over here at the A and the Z, I'm gonna hit that guy. Now, when you hit this, though, you want to do is hit custom sort. And then under custom sort, I do want to expand the selection, not just have just not that one row. I want to do everything. So when I hit sort, it's not going to sort right away. What it's going to do is ask me what I want to sort on. So I'll bring this over here and I'll say I want to sort on, and I hit the first divots and I come down to ID. So what that'll do is sort the entire spreadsheet into SRC1 at the top and SRC3 at the bottom. And I hit OK, it should, there it is. See, SRC1s are done. And then I come down far enough, there's the SRC3s. So I should be able to um, pull in those magnitudes for each one.
But you have to
Now,
choose it. I think, John, you have to
mhm.
choose it all of them and sort it out based on that, because otherwise it's sorted. If it's sorted based on the ID, do we make sure that it's sorted on the other columns also the same?
It should have 24589111. See, 2458. Yeah, it did. So
Okay, okay, good. Yeah,
it's everything else is synced to the data. Everything is synced to that spot. So we didn't lose anything. It's kind of nice. So I did, I'm highlighting the magnitudes for this first one, and I'm going to copy and paste that into my Astromancer as source one.
yeah, that's the easiest way. That there is a lot of some of this Excel file, especially on the lab 5 and 6. We needed to do some extra work on the Excel file. But as long as those we can align it and we can bring it an Astromancer, we can get the graph easily assign it based on that measurements.
Yeah. So you have a couple options, I guess. You can do each one individually and then put
Yeah,
them in, or you can just do the one.
yeah.
All right. I like that.
And also we have to choose the three items. One is the magnitude of the reference file source one and magnitude of the parallel source three, and then Julian day. Also, there is a item as you choose it right now, Julian day. That's gonna be, I guess, gonna be similar for both of them because picture is the same. Then you can copy column by column, and you get the graph accordingly.
Yeah. So that's where I'm at now. I went ahead and I put I copied just like that. I did the top stuff as source one, the bottom stuff is source two,
Very
and then I
good.
put the Julian date. And I can see some periodicity in here already, it looks like.
Yeah. Yeah, the things that you needed to do right now, you just choose you can rename it one of them accordingly, but you have to come for the source one and you choose it kind of as the graph is changing. You have to add a kind of chart on it for each of them as a kind of graph. Yeah,
Yeah, how do I get my curve on this? I'm trying to get
yeah,
the curve. That's not the light curve. Burritogram, that's not it. Not sure
yeah,
why it's acting like this.
yeah.
There, didn't happen. Okay. Hmm. Yeah, I'm not getting the I'm gonna go ahead. Should I stop sharing? I'm not sure why that's not putting didn't put a curve on top of it like it should. I'm not sure why it's not.
Let me do that myself. Just
Yeah.
give me.
I got the points. I can definitely see there's a periodicity to it.
Okay. When we go here, let me do it. Previous things that we had. I show it with the variable star here on the graph. Let me bring it the same way.
Hmm. X-axis, Y-axis. Short period in, period 1 day. Eight days.
I'm seeing a large gray rectangle of death.
Yeah, there's nothing coming through on our end. Ron, how are you doing? You able to copy paste that or sort that out okay?
I'm still copy and pasting the errors into it.
Well, the errors. I didn't do the errors. That's a good idea. Not very much. Hmm. Yeah, usually you get, I'm not sure we're not
Oh,
getting
we're
a
seeing
curve on.
something.
Oh, there it
Uh,
comes. Oh, both on top. Yeah, I got gray again. Just one up here. Oh, that went through. Oh, it just must have taken a while for mine to go through. It looks kind of weird though, but I think oh, that's weird. I've got a log base axis on the bottom. I don't know why it's doing that.
um, Out of curiosity, once this is completed, what sort of curve should we be seeing?
We're gonna see it like this, a kind of curve as you see it. You see my screen on the afterglow on the web assign?
Yeah.
Yes.
Yes.
Yeah, here we're gonna see this kind of curve. When we see this kind of curve, if, for example, on the procedure that we had, like the one that you see it on here, Lara Larry, this is for NGC 1261, and here same thing. And when we're getting this one, the time between the uh, two peaks that we're gonna get from here to here, we calculated, for example, here as you see it is around, you can go and measure it actually by the cursor for each of the peaks, and then you provide it here. Then if it is less than a day, it shows that is consistent, period is consistent with a star being Larry. And then the absolute magnitude is 0.75, and therefore this shows you're gonna put it here. And the next question, estimate average apparent magnitude M. That is, you're gonna come and calculate based on the formula that we had it here. Let me show you again, RR here. Yes, we have a period. When you have a period, this is for the Cepheid.
I've got data for the light curve. I got data now for the periodogram. I don't
Yeah,
have anything for the
because
period
here
folding yet.
you get the what you call it magnitude that you had here. You can get the calculate the magnitude accordingly. Here, as you see it, and you identify this based on the graph, peak to peak, and this is show that is RLARY, and absolute magnitude we know. We don't need it to calculate. And then based on the graph that we had it, this is apparent between the peak and the lowest part of the graph. We know the peak on the graph and the lowest part, and we calculate this is going to be apparent magnitude. And when we have apparent magnitude M, and we calculate D based on this formula. Where was the formula? It's here. You see, M is going to be calculated based on the peak value here, and M going to be calculated between the peak and the lowest amount here. And then D, we're going to calculate it based on this formula. Therefore, we know M for the RLA, and we calculate M from the, what do you call it, the distance between the top and bottom. And then based on that, we calculated D from this formula that is showing on the procedure on the web assign here.
Huh. Mr. Taylor, have you had any success with producing a curve yet?
Well, the light curve one didn't do anything. The periodogram, though, I've been looking at that. That is, I've got a nice peak at 0.5596, and the magnitude, that would be right, 0.002963. Star magnitude. So I'm not sure if that's what I can do. I need to look back at the instructions, make sure I'm doing this right.
When I select source 2, the graph looks more sinusoidal. It's just there's a lot of noise off to either side. There are like concepts of a curve um when you select the RR Lyrae.
Let's see it here. As you see it, do you see one of them is blue and one of them is the green in your spreadsheet in
Yeah.
the graph?
Yeah, when I select none, yes.
Yeah, you have to select none to see it on each. But if you want to select the one, select the one. It's going to be what to call it, the reference file. Do you see my screen?
Yes.
Yeah, okay. Here,
It's the same.
as you see it, this is not very constant. Reference going to be constant. But if you consider the difference between this top one and lower one, it's going to be around between 14 to 12.25 is changing. This is source one. And if we go to the source two,
Okay.
also is fluctuating differently. But here, let me eliminate this one. There's source two. I just identify this. This is a reference star actual magnitude. The reference star actual magnitude is 13.6. You have to identify here, either on the source one and source two. Therefore, you have to identify in here. But the next thing that you have to identify is the one that you see it in here. As you see it on the, what you call it, the variable star is the second one, right? And then you go choose which one is the toughest one. As you see it here, toughest one is about some number 13.2. And then when you go to the next periodogram, here you provide some title on it. I assume the title is here. And then the things that you needed to provide some numbers here. You see here the numbers is 0.1 and end the period is 0.1 day. You come back here, you see the days that you had here is based on the uh, Julian day that you are already provided. And here you have other thing, start day 0.1 and 1. Therefore, because of that, you don't see it anything. The reason is that for here, it's better to identify those one of the uh, uh, what to call it, the this picture that we have to make it this graph on the constant way to make sure that to get some data from it. Therefore, here I will do this way. For example, I come here, copy, and I go here, paste, and come to the bottom. Copy. I go here, paste,
Oh,
enter. Okay. And it should choose something here is, no, the two numbers are the same. Let me see. I
Yeah,
get
I'm dark here as well. I'm the periodogram doesn't seem to be doing it.
yeah, because that's it seems to be something wrong on the transferring of the Excel file. That's the problem that we had. I think we have to make sure that because it doesn't show, there is something wrong on the Excel file that we created. I think we needed to do a kind of, again, to investigate, make sure the numbers that we have it here is correctly transferred. And I think this is the issue with the Excel file, that the way that we transfer it, probably we just didn't do proper sorting of the Excel file. I think
Um,
I I may stop this one here as we pass the hour, and then next week we're gonna go this one again with the Excel file Astromancer, and then we're gonna do the same thing on the one of the uh, Cepheids and the supernova, and that's gonna complete the next week. Gonna be we're gonna focus on the transferring the data from Astromancer to the from the Afterglow to the Astromancer and Excel file, and make sure that we correctly review the steps and learn on those.
um,
sounds great.
Professor, when you set the period here to 48, you can sort of see like the curve of the graph like bouncing up and down there.
Yeah,
And
yeah.
the start points of the curve seem to match up where you pull the period all the way out. And number two, is our last class next week or next week?
Next week.
Okay.
Yeah, therefore, this next week we're gonna go over. I think half of the next week we're gonna be we review the procedure of the lab 5, and then we're gonna start doing the lab 6. On the lab 6, you're gonna observe several galaxies. We're gonna measure the size of the galaxies over there. Lab 6. Therefore, on the last one, that the next 2 weeks, we're gonna have some procedure for the lab 6. Therefore, next week gonna be half and half on the lab 5 and lab 6, and the last session on the December when it's gonna be 18, gonna be to show the procedure for the lab 6 and end of the class. Okay.
Yeah.
Okay, therefore, hope you have a good night, and we just staging the. We don't have on the lab 5. We don't have any picture to taking. If you have something left from the previous labs, you can continue, and then for the next week, we're gonna have some new pictures on the galaxies that we're gonna take. You can review the lab 6 if you need it. You can take a pictures ready for that, or wait for the next week. We start the picturing. Okay.
I think okay.
Yeah. Okay. Have a good night and see you
Thanks,
next week.
boss. See you, Ron.
Yeah, you're welcome.
Night.